lesson 4.2.2, so part 2, so to speak. And we are going to be using, so we are working on our trig values, right? Knowing how to find sine, cosine, tangent, and then also cosecant, secant, cotangent. So what we are doing right now is when we look at our unit circle, okay, which I know we don't have a whole lot of knowledge of that unit circle, but there are certain parts on that unit circle that you need to know what the values are. Okay, so when we look at, for instance, pi over 6, that's one that you need to know. You need to be able to just tell me the cosine of pi over 6 is this. The sine of pi over 6 is this. The tangent of pi over 6 is this. Okay, so definitely some memory work involved. However, there are also ways that if you forget a piece and you don't have it memorized, that you can create that chart. And that's what we're going to talk about today. So back in geometry, you learned two special right triangles. You learned the 45, 45, 90 and the 30, 60, 90. Ring a bell? I'm not saying you remember anything about them, but you learned about them. Okay? So these two triangles help us with creating our trig chart here. So do we remember anything about a 45, 45, 90? Okay, so there's two key facts in a 45, 45, 90. One is the legs are equal, and that's because the 45-degree angles are equal. The sides opposite them are the same. So one key point is that legs are equal. Do you remember any connection about the hypotenuse? No? What if I throw out square root of 2 for you? How do we find the hypotenuse? Square root of 2 times the length of a leg. Okay. So the other thing you need to know about a 45, 45, 90 triangle is that the hypotenuse is equal to the square root of 2 times the length of a leg. Doesn't matter which leg, of course, because the legs are the same. Okay. I'm hopeful that is a little familiar to you. This is part of this just needs to be memory here. Okay. If I ask you what you know about a 45, 45, 90 tomorrow, you need to know it. So now, when we're going to use this for our chart here a little bit, what I'm going to do is I'm going to assign the legs the value of 1. So if we say that the legs each have a length of 1, what does that mean about the hypotenuse? The hypotenuse has a length of square root of 2. And as I said, we'll use that to create our chart in a little bit. Okay, the other one up here. 30, 60, 90. I'll ask, just in case. Do we remember anything about the 30, 60, 90? You didn't really remember a whole lot about the 45, 45, 90, so. Good. You don't know where, but okay, I agree. Square root of 3 is in there. Square root of 2 goes with the 45, 45, 90. Square root of 3 goes with the 30, 60, 90. Okay, so when we talk about the 30, 60, 90, I'm going to call my three sides the short leg, the long leg, and the hypotenuse. Okay, so the short leg is going to be opposite which side? Yeah, the short leg is always opposite the 30, and I'm going to call that length 1. I usually start with the hypotenuse, and the hypotenuse I'm going to call length 2, meaning the hypotenuse is equal to what? 2 times the short leg. So that's one key piece of information you have to know here, is that the hypotenuse is equal to 2 times the short leg. And now we get hold of square root of 3. Square root of 3 goes on the bottom side here, which is what I will call the long leg. And so how does my long leg relate to my short leg? My long leg is square root of 3 times the short leg. Okay? Know those triangles, guys. That's geometry. I realized 2 years ago, probably, but know them. When we take, probably next week, we will take a quiz over this chart that we're getting ready to create. And one of the things I have, it's a very quick, like 5-minute quiz, but one of the things I have on the quiz is being able to label these two triangles. Okay? It's because they are so important for creating the chart. So, this chart, we'll draw it a bunch this year. First of all, there's 3 degrees along the left column, 30, 45 degrees, and 60 degrees. I will probably get them labeled on my unit circle here before long, but 30, 45, and 60 all fall in that first quadrant. Okay, they all fall between 0 and 90, obviously. Now, radians. You need to be confident in what each of these are as radians. How do I figure out what 30 degrees is as radians? What do you guys remember from Thursday's lesson? Yeah, you multiply by pi over 180. So if I take 30 and multiply by pi over 180, what is 30 times pi over 180? Pi over what? Not 5. 6. Okay, 180 divided by 30 is 6. And so in terms of radians, this is pi over 6. That's one you'll just learn. You'll need to know. 30 degrees is pi over 6. Let's go ahead and get these done. 45 degrees. What is 45 degrees? If you multiply by pi over 180, or you can kind of guess looking at the unit circle over there. Pi over what? Pi over 4. Okay, 45 goes into 180 4 times, and so it is pi over 4. What about 60 degrees? Then multiply by pi over 180, 60 degrees becomes what? Pi over 3. Okay. You'll notice those are all right there in that first quadrant of the unit circle. Come up with your own memory techniques. I tend to remember the 6 and 3 are switched. 30 is pi over 6, 60 is pi over 3, and then 45 is pi over 4. They both have the 4 there. However you want to remember them, but know them. Okay. Sine. This whole row is 30 degrees. So, this is where triangles come into play. Sine of 30 degrees. Any thoughts on what sine of 30 degrees is? It says 1/2. How would we get that? Okay, we talked on Friday, opposite over hypotenuse. So, opposite over hypotenuse, 1/2. I'm going to say let's go ahead and continue along on 30 degrees. Cosine of 30 degrees. What's cosine of 30 degrees? Square root of 3 over 2 because it's adjacent over hypotenuse. And tangent. What would you say for tangent? Opposite over adjacent, so 1 over square root of 3 is what you come up with initially, and I will accept that. However, you need to be familiar with what this is equal to when it's rationalized, because more often than not, we see the rationalized version. What is this when it's rationalized? Square root of 3 over 3. Thank you, Haley. Okay, because how do we rationalize? We multiply by square root of 3, top and bottom, right? So it becomes square root of 3 over 3. When it comes to you writing something down for me, like on a quiz or something, I'll accept either or. As I said, get in the habit, though, of putting the rationalized one, because that's the one we'll use the most. Okay. 45 degrees, pi over 4. Have you started filling them out? Now, does it matter which 45-degree angle I pick? Nope, doesn't matter. So, sine of 45 degrees, what do you got for me? 1 over square root of 2, opposite over hypotenuse. Now, same thing as previously. I will accept 1 over square root of 2, or what is that equivalent to? When you rationalize it, multiply it by square root of 2, it's square root of 2 over 2. What about the cosine of 45 degrees? It's the same, yes? Because sine was opposite over hypotenuse. This is adjacent over hypotenuse. So, 1 over square root of 2, or square root of 2 over 2, whatever your preference is. And lastly, tangent. Opposite over adjacent is 1. 1 over 1 is 1. Okay, and 60 degrees. We need the sine of 60 degrees. Okay, you got it? Going from up here, right? Sine of 60 is what? Square root of 3 over 2. What about the cosine of 60? Here's my 60 cosine. Adjacent over hypotenuse. 1/2. And lastly, tangent. Tangent of 60. Opposite over adjacent, which is going to be square root of 3. Okay? There are some connections to be made on this page, right? Do you see some of the connections on this chart? Okay. For instance, sine and cosine of 30 and 60. I always start, when I start filling up my chart, I start with 1/2 in this top left corner box with the sine of 30. Notice what's down here at cosine of 60. Also 1/2. Cosine of 30, square root of 3 over 2. Notice that's the same as sine of 60. So those two flip-flop. Notice sine and cosine of 45 are the same. If you know one, you know the other. Another good thing, tangent. My tangent are reciprocals of each other. And this is where it's helpful to look at, if you say the tangent of 30 is 1 over square root of 3, one of the few times I like to look at that version, because then the tangent of 60 is square root of 3. Okay. The deal is going to be, can you create that chart on your own? Because we'll use that a lot. Now, continuing along with that, find the cotangent, secant, and cosecant of each of the three angles from above. So basically what I'm going to do is I'm going to make this chart again, except this time instead of having sine, cosine, tangent, cosecant, secant, cotangent. I'm not going to go in the order of the question. I'm going to go in the order of the chart above. So, your quiz that we'll talk about early next week, I don't think we'll get to it late this week. I think it'll be early next week, that has this chart on it. We'll have both charts. So, my first column is going to be degrees still. My second column is going to be radians again. Okay, sine was right here. What's the reciprocal of sine? No, okay. Which function is the reciprocal of sine? Secant, cosecant, cotangent. Cosecant. So I'm going to put my cosecant column next, was my point. What's the reciprocal of cosine? Secant. And then the reciprocal of tangent, cotangent. And then what are the same three rows we need? 30 degrees, 45 degrees, and 60 degrees. Okay. So, let's fill in the radians. What do you know about 30 degrees? 30 degrees is pi over 6. What's 45 degrees? Pi over 4. And what's 60 degrees? Pi over 3. Okay, so how do I do the cosecant of 30 degrees? It's reciprocal of sine of 30. If sine of 30 is 1 over 2, then cosecant of 30 is 2 over 1, which is 2. Okay, what about secant? Secant of 30 degrees is going to be the reciprocal of cosine, which means, what am I going to say? Yeah. So, if we just flip it, it's 2 over square root of 3. The rationalized version is 2 square root of 3 over 3. What about the cotangent of 30? Reciprocal of tangent, which is?
Pardon the interruption. At this time, Mrs. Buchanan's textile classes need to report to the sewing room. Ms. Buchanan's textile class, please report to the sewing room.
Okay, so and this is where, again, one of the few reasons I like this, 1 over square root of 3 flips to be square root of 3. Okay, 45 degree row, you got it? What's the cosecant of 45 degrees? Square root of 2, it's the reciprocal of sine. Secant, if cosecant is square root of 2, guess what? Secant is square root of 2. And cotangent, the reciprocal of 1 is 1. Okay, 60 degree row. What's the reciprocal of sine of 60? Okay. 2 over square root of 3 or 2 square root of 3 over 3. What about secant of 60? Reciprocal of 1/2 is 2. And cotangent of 60. Yeah. Reciprocal of square root of 3 is 1 over square root of 3 or square root of 3 over 3. Okay, guys. You'll want to work on either memorizing where everything is on those charts or knowing how to create them, how to fill them in. Now, in homework, you have, if I think correctly, you have 3 sections in homework. Some of your homework, and maybe we'll get a chance, I can talk about it, but some of your homework will be, okay, actually I should just open the book and look. When was it? So I want to prepare you. So 19, the very first problem you have to do in homework tonight, says evaluate without using a calculator. And you know what 19 says? Sine of pi over 3. No. Okay, so it's not asking me what pi over 3 is equivalent to. I agree, pi over 3 is 60 degrees. I could rewrite this same question to say, what is the sine of 60 degrees? But these have the same answer. What is the sine of pi over 3 or 60 degrees? 60 degrees and sine. Where do they meet? Square root of 3 over 2. So your first answer for homework is square root of 3 over 2. Okay? 2 of your 3 sections of homework tonight, if I recall correctly, say without using a calculator. You give me a decimal answer on that, I'm not giving you credit for the homework because you didn't read the directions. Okay? You're using your chart. Okay? And one of the other reasons I went through this, common mistake. Sine of pi over 3 is 60 degrees. I'm not looking for the angle equivalency. Okay, yeah, I'm looking for what is it from this chart. Okay? Now, I say that because, so that is, what, 19 over 20, 19 to 24 without using a calculator. 29 through 40 you do use a calculator. And then 41 to 48 is back not using a calculator. Okay? Let me show you 41 real quick. Just giving you guys an idea. It says, I think that's what it was. 41, sine of theta equals 1/2. Find the angle that satisfies the given condition, your equation. Give theta in both degrees and radians. You should do these problems without a calculator. So again, go to your chart. Sine of theta. When does sine equal 1/2? Yes? 30 degrees and pi over 6, because those are the same thing. Those are the answers I'm expecting on that section. Okay, so I just want you to see. That's how you're going to be using the chart. Got it? So you got 2 free answers for homework already. What's number what?
20.
I don't know the answer number 20. We'll talk about the answer 29 here in a second if you want. But now, okay, example 2. It says evaluate each of the following on a calculator. Be sure to make sure you're in the correct mode. As you look at example A here, sine of 15 degrees. Why does it say to use a calculator? Can I not just go up to my chart? Why can't I go to my chart? 15 is not on my chart, is it? Okay, so grab your calculators, everybody. Make this a requirement. Okay? How do you find sine of 15 degrees? You what? You hit sine and you type in 15. And if luck is in your favor, you got the same answer as me. If luck is not in your favor, you're in the wrong mode. Did you just type in a degrees or a radians angle? It said 15 degrees. Notice, my calculator tells me up front, and I'll make sure everyone knows how. Does your calculator say degrees up there? If it says degrees up there, you should have gotten the same answer. If it says radians up there, that's why you're wrong. Now, here's how we change our mode. You will go back and forth a lot in this chapter. So we go into mode, which is right next to my second button. Do you see it? Notice on mine, degree is highlighted. If you got that answer wrong, radians is probably highlighted, right?
Yeah.
So to change it, just go down, hit enter on whichever one you want, clear out of there. Notice it says radians. Now my calculator's in radians. If I go back, hit degrees, now my calculator's back in degrees. There's got to be a way to change your mode. I just don't know how, Jordan.
Oh, I already got mine.
You already got, okay, good. Okay. I was like, oh, I'm stressed. I don't know how to change yours. Now, did everyone get a matching answer for me? Yes? Okay. So that's going to be the most difficult thing in homework tonight. Remembering to change your mode. In my notes, I have 3 decimal places. So what is this to 3 decimal places? .259. And the big catch there is, did you make sure you were in degree mode? And I knew I needed degree mode. Hello, because there's a degree bubble. Can I make it more obvious there? Okay, you ready to try B? Cosine of 5 pi over 7. If you happen to be watching me, the first thing I'm doing is I'm going in and changing my mode. You could either enter it with a fraction bar or just with division sign there. Oh, dang it, sorry. Thought I was typing the whole time you up there. Does your answer match my answer? If not, did you get your mode changed? And then did you type it right? Let me help you with your calculator issues if you're having them. So if I give that to 3 decimal places, negative 0.623. And what mode did we have to be in to get it right? Radian mode. How did I know to use radian mode? Okay. The pi is a good indicator, but most importantly, there's not a degree bubble. Because they could say 5 pi over 7 and then put a degree bubble on it, and it's degrees. Okay? They could also give me a radians that is 30, but not putting a degree bubble on it makes it radians. Okay? Now, generally speaking, do they do that kind of stuff? Not usually, but. Okay, moving along. We've got I don't want to run out of time here. What's the catch on C? It's kind of degrees, but can I enter minutes and seconds on my calculator? No. So we are going to need degree mode. Do you remember from last week how to change that to flat out degrees? Yeah. So it's going to be the 57. You're going to add on, you're going to take your minutes of 13, divide by 60, and your seconds of 15, and divide by 60 squared, or 3,600. So first thing I'm going to do is I'm going to change that. And so what I'm really doing here is that 57.22 number. So when I do this on my calculator, I'm going to be doing the tangent of 57.22083, so on and so forth, degrees. Now, my recommendation, one of 2 things. When you go to do the tangent, I would not recommend you round what you used to do the tangent with. That's okay, because my calculator is easy to do this. Because what do? I hit the tangent button. Do I need to type 57.22, so on and so forth? What can I do? Arrow up, highlight it, grab it, and now it carried down that whole value. Now, I'm realizing, is mine going to work out? What is this 57.22 number? Is it degrees or radians? Degrees. Am I in the right mode? No. So I'm going to change degrees before I hit 2 degrees before I hit enter. And now I got it. So tangent of that 57 degrees, 1.553. Did you get it? If you really wanted to, guys, you could have just typed in tangent of 57 plus 13 over 60. Whoops. Dang it. Plus 1500 over 3600. You could have just typed it in right there, and it would have worked for you as well if you didn't want that extra step. Okay? Calculators will do a lot for you, right? Okay. Bottom row. Can we get through these real quick? Set up like this on purpose. What's the first thing you notice about this cotangent problem? First of all, you need to go to radian mode. So mode, radian. I can just hit clear and it gets me out of there. Now, cotangent. Do you have a cotangent button? No. But it's the reciprocal of tangent. Now, there's a good way to do this and a really bad way to do this. When you do this, you cannot use the tangent -1 button. That is inverse, which is different from reciprocal. It will get you a wrong answer. What you need to do is you need to do the tangent and then raise it to the negative first power. Because the negative first power causes something to what? Causes it to flip. Now, on my calculator, I can just type it as is. So I can do regular tangent of negative pi divided by 10 in my parentheses, and then you can raise it to the power of -1, or on the left, do you see that x to the -1 button? You can hit that if you want. That's raising something to the power of -1. And this is the answer you should be getting if you've done it right. -3.078. Okay? So, use reciprocal, you raise to -1 power. Do not use the tangent -1 button. That's inverse, that's totally different. Okay, there you go. So, what about this next problem? Secant of 87.36 degrees. First of all, your mode has to go back to degrees. What's the reciprocal of secant? No. Cosine. So you're going to be doing the cosine of 87.36 degrees raised to -1. If you want to check your answer later, I will tell you it's 21.711. And as you're packing up, I'm just going to write in, on this last one, cosecant, you would end up doing the sine of its 7.1716 degrees to the negative first, and it is 8.010. Do the homework for tomorrow. Yes, it is due tomorrow. Okay? Just giving you some things you can check with and play with your calculator. Homework is page 335, 19 through 24, and 29 to 48.